This webinar is focused on the boundary fit functionality in Geomagic Design X. I appreciate you joining us today, and I hope you're able to join us again on future Product Spotlight webinars. I will now pass it on to Tobias Klein, a Geomagic support specialist, as he's leading today's demonstration. Tobias, it's all yours.
Thanks, Ralph, and hello everybody. Today we want to have a closer look at the boundary fit surfacing tools inside Design X. Boundary fit surfacing command basically uses curves from 3D mesh sketch as boundaries for surface patches. Both the curves from the 3D mesh sketch and the surfaces are fitted onto the mesh with controllable tolerance and smoothness. There are several methods available how to create those curves, depending on the shape of the mesh and also depending on the design intent. For an organic topology, like shown in this image series, it is possible to trace feature lines and extract curves directly from the mesh. And in case of more designed or engineered topology is needed, the curves can alternatively be constructed in a 2D sketch first and then projected onto the mesh in order to get a more defined surface segmentation. In conjunction with the smoothness and tolerance options, the result can be tweaked between very accurate representation of the actual shape or a more idealized design shape. Boundary fit surfacing command can be used in various situations where a pure parametric approach would be too time-consuming or just impractical. The most common applications are aircraft skins, car bodies, generally organic shapes, various kinds of blades, as well as molded parts. In today's demonstration, I will show how to create or extract curves from a mesh, or alternatively how to project a fully constrained 2D sketch onto the mesh, how to use the boundary fit command to create the surfaces, and how to use the accuracy analyzer functions to evaluate the quality of the surfaces to ensure they are ready for exporting. So here we are inside Design X, and here we have a mesh of the backrest cushioning of a chair, and we want to get a surface from it, and we are using the two-step method of boundary fit surfacing. Boundary fit surfacing command is here. It is available when we have a 3D mesh sketch. So first we need to create that 3D mesh sketch. We need to go in here and select 3D mesh sketch from the 3D sketch tab. And we have several methods to create that. There's a manual way to go in this command trace feature line, for example. We can click here and get this character line. This is searching for a curvature threshold up and down, and we can also define a certain smoothness. We can also click in another area or, with wrinkles, for example here, and the threshold is a little bit bigger, so we can define start and end point of that portion which we want to have, and then right click and check OK if we want to keep that. And we can also get an offset of those lines here, for example this and this line, and remove the original curve so we can get only the offset curves. And then we can create splines manually, for example go from here to there directly and go from here to there directly. And as you can see here, the splines are only 2 points splines, and we can increase the we can decrease the allowable deviation to 0.1 to automatically increase the number of points to a necessary amount of points in order to stay inside the tolerance. So the splines automatically projected. In this case 0.1 millimeter, and the splines automatically projected. Then we can also merge those splines together. And we have one continuous spline but this continuous spline has an uneven number of points. So to even the number of points out, we can just select the spline and then just enter a different number of control points in here, let's say like 50, and click OK. So now we have an even number of control points along the spline. Finally, we can go and use the boundary and extract the boundary from this mesh. And we can also go in this curve ends dial and scroll the mouse wheel up until we can get these yellow circles to find the curve ends. And click OK, and they will connect to the curve. And also here is one that was a little bit further away. We can pull it manually. Also for the intermediate, for the intersections, we can go in here and click OK to build the intersections automatically. For the boundary fit surfacing, every spline that goes through creates a G2 continuity between adjacent faces, given you have 4 boundary patches. So if there is no 4 boundaries, so for example this case has a third boundary only here, which is curved, then this will be a trimmed surface. Every 4 boundary patch will be a G2 continuity with the neighboring surface. So this setup is quite good. We can save it for later, and I will also show the second method to extract contour curves. Extract contour curves is basically segmenting the mesh curvature based. So it's looking curvature sensitivity, and it's looking with a separator sensitivity. And if I go to the next stage, we can see a preview. And I can either go and with this paintbrush and control key, I can remove lines. I can remove areas where it should not search for curvature changes, and press this looking glass, and then it will update so that it doesn't draw these lines. Or I can go back and reduce the curvature sensitivity to, let's say, 260 and calculate again. So it will generate much less curves in this case. Also here again we can use the offset for those curves, but in this case the curves are already connected, so the offset is not exactly working this way. Should disconnect the curves first. So this is basically the curve network. And there is a third method to create those curves in 3D. I already created a 2D sketch. And this 2D sketch is created with lines and arcs and dimensions. And yeah, if you need a more mechanical approach, then you can create your 2D sketch. And then you can go ahead and to get from a 2D sketch to a 3D sketch, we need to create a 3D sketch first and project the 3D sketch. So create that 3D sketch, which is actually detached from the mesh. Use convert entities and select the 2D sketch completely. Now I have a 3D sketch. And inside that 3D sketch, I can delete lines I don't need. So for example, those lines I don't need, and I don't need the center lines. And I want to make sure that everything is connected, so I can select everything and rebuild just with the same number of control points. And then also make sure that everything is connected. I can click in here and connect the endpoints. So that is the 3D sketch, and now we want to project that 3D sketch. This command is in here. So we select the target entity and we select not minimum distance, we select along a vector. And in this case, it is our sketch plane, the normal vector of our sketch plane. And we select which curves or nodes we want to project, in this case, everything. And now we can see every curve and node is projected up to our scan, up to our mesh. And after clicking OK, our 3D sketch is now projected onto the mesh. And the final thing we need to do is we need to convert it into a 3D mesh sketch. So just click on 3D mesh sketch, click on convert entities and select all lines, or you can just also select the 3D sketch completely in the tree and convert it. And now the 3D the curves are 3D mesh sketch curves. That means every node is attached to the mesh. And we need to make sure that the lines are connected. So just by clicking into the curve ends. And when that is done, you can also check by hovering the mouse over each curve. You can check how many control points and so on. So we can also say we want to have 10 control points per curve only to reduce the overhead a little bit. We stay still inside the tolerance. So if we click one curve, we can still check the tolerance. Okay, so that is the third method. And now we can go into the add-ins menu and we can go into the legacy boundary fit. And that's the same for all three methods actually. But in this case, we can choose the mesh curves. And here we can also choose which loops we don't need. So in this case, we don't have a boundary, but we have our designed sketch-based curve network. And here I go into the next stage, and here I have the visualization of the U and V axis of each surface, so in green and red. Like the X and Y axis in the coordinate system, the U and V axis of each surface patch is green and red. And I can define how many control points I want per surface axis. So for example, I want only 5 in this direction. And I want only 5 in this direction. And the others I want 15, for example. And I can check the preview, and now it's basically calculating the fitting surface onto the mesh. Now we can see already the preview. And here in the accuracy analyzer, I can check the deviation colors. So this is 0.1 millimeter, less than 0.1 millimeter in the green area. Of course, in this seam area, we choose a lower number of control points, so that is not as accurate, but we want to have that because we chose a lower number of control points around that area. Now if I switch to the environment mapping, we can also check the surface quality. So in that case, we have each bump and dimple we want to have. And in the upper area, we want to have less bump and dimples. So we want to have a higher surface quality in that area. And that looks also pretty good. And finally, we can also check the surface segmentation, which is the UV lines actually of the surface. And we can finally build the surface. And I just saw in this case, we might want to increase the tolerance to 0.1. And since everything is parametric, the boundary fit command is parametric to the mesh sketch. It's calculating again, and our boundary is nice again. So that's finally our surface, and we can also check the continuity in position accuracy, the position tolerance between the surfaces, and we can check the tangent continuity and the curvature continuity. And of course we can check the other things like curvature and the environment mapping. And that concludes the demo. Thanks.
Thank you, Tobias. That brings us to the end of our Design X Spotlight webinar, which walked you through the boundary fit function in Geomagic Design X. You learned about how you can handle mesh data, how to create curves on meshes, how to use boundary fit to create surfaces and to verify surface accuracy.